Hello, today I am going to solve Codeforces 2240A, which is another pop count. So in this question we have been given two integers n and k, okay, and we have to form an array of k integers whose summation is less than equal to n. The sum of all the elements in that array should be less than equal to n, and the pop count should be as large as possible. Okay, the pop count should be as large as possible, and we can see here what pop count actually means. It is the number of set bits, matlab the number of 1 in the binary form of that number. So to solve this question, I have used an approach and I will tell you that. So first of all, we have to think that we have to maximize the number of bits. So like if we think if we think powers of 2 like 4, okay, 4 4 or 8 or 16, okay, so in this we can write its binary form. We can write its binary form as 100, okay, this is 1000 and this is 1000. So in less than one, this like for this 3, for this 7, like 2 to the power n minus 1, I am telling, for this 15 we get this binary form 111. For this we get 1111. Sorry, my bad. For this we get 111, and for this we get 3 ones, and for this we get 4 ones. This is binary representation of 15. This is binary representation of 7. This is binary representation of 3. Okay. So we know now that maximum bits we can use is like 2 to the power n minus 1. All the numbers which are 2 to the power n minus 1, they have maximum bits, maximum set bits. So we will try to form an, let's say, an array of k numbers consisting of only 2 to the power n minus 1 numbers. Okay, so this is k. So let's say k, like let's say for 3. Okay, I have to form the summation of 3. So what can I use? I can use 3 ones. Okay, I can use 3 1 or 1 3. So if I use 3 1, I get 3 bits, 1 1 1. But if use 1 3, I get 2 bits, 1 and 1. So now from this we can understand that the lesser the number is, the more the bits will be. Okay, so for now let's calculate the like, yeah, you understand, like if I have to form, let's say, 5, I can use 1 1 5 ones, or 3 I can use 3, then 1 and 1. Okay, I can use only 5. So in this I get, like, let's say 7, my bad. Okay, so I can use 7, I can use 3 3 1, I can use 7 ones, 1 1 1 1 1 1 1. Okay, in this we get 7 bits, but in this we get 2 plus 2 plus 1, which is 5 bits, and in this we only get 3 bits. So it is always we choose the smaller number. That is the most optimal way. So let's fill it up. So for now I have k. So if k is less than equal to n, for that case there are k places and these places are less than equal to n, then I can fill till n. Okay, till n I can fill 1, and this will give me the maximum number of pop counts. If I use any other numbers, it will always be less than this, the number of pop counts. So for k less than equal to n, I will return what? I will return n itself. Okay, that n will be the number of pop counts. For now, if k is greater than n, okay, then I will try to fill this with like 2 to the power, which 2 to the power n minus 1 fills it such that fills k numbers such that it is less than equal to n. Let's say I have 3. Okay, k is 3, and I have, let's say n, let's say I have n equal to 12. So can I fill 1? Yes, it. Can I fill 3? Yes, it is still less than equal to n. Can I fill 7? 7, 7, 7? No, I cannot. It is more than 12. So I will choose this one. Okay, I will choose this one. So let's fill this 3, 3 and 3. Okay, 3, 3 and 3. I filled this, and now my total sum is 9. So how much sum have I left now? How much sum do I left? Have I left? Let's say n is not 12. Let's say n is 14. Okay, let's say n is 14. So yeah, in even if it is 14, if it is 14, still I cannot choose 7, 7, 7. This will be 21. So I choose 3, 3, 3. Okay. Now how much have I left to go till n? That is 5. And how much is the difference for 7? That that is 7 minus 3 equal to 4. So I can use here 7. That is what I am trying to tell you. I can use 7 here. So 3, 3, 7. Okay. This is now 13. And this thing will have is less than equal to 14, and this thing will have the maximum bits. So all I'm trying to say is, if there are k bits, there are k places, I can fill them like something like 3, 3, 3, 3, then 7, or else 7, 7, 7, 7, then 15, 15, 15, like this, or else 15, 15, 15, then 31, like this. Okay, so I will till n I will calculate the number of, like, for which number it is less than equal to n, for which here it was 3. Then I will calculate the remaining, like I will calculate the difference, and I will try to fill the difference using its next number. Okay, because if I don't use next number, why? If let's say let's say I had here 16. I had here 16. No, I had here, like, you can verify yourself. The maximum bits always be like 2 to the power n minus 1, and the remaining will be 2 to the power n plus minus 1. It is always possible. Okay, because the smaller the number is, the more will be its bits. So if we take something more than 7 here, leave the sum. If so more than 7 here, then the number of bits will be increased there, but I cannot take other sevens. So, like, maybe you have understand till now, but if not, let's take another example. Let's take 4. Okay, and maybe let's say 37. Okay, n is equal to 37. So 1 comma 1 comma 1 comma 1 possible, 3 comma 3 comma 3 comma 3 possible, 3 into 4 12 possible, 7 into 4 28 is possible, 15 into 4 is 60, which is not possible, so we will first choose place 7. 7 7 7 7. Now how much difference is left? Okay, that is 37 minus 28, which is 11. So now 11 is left. So can I fill something here? Yes, I can fill 15 here. Now the pop count is the maximum for 37. Okay. So how will we calculate this? So to calculate this, we will first calculate till which number I can fill it. Like for here it was 7 7 7 and 7. Okay. Now I will calculate the total sum, that is 28, and for that is 37, which was 11. Now I will choose what is the difference between 7 and 15. That was 8. And is 8 less than 11? Yes, 8 is less than 11. So I will first fill one place plus 8, which becomes now 15. So like that, if there was something here, let's say, what can, let's say 17, maybe, then we could have filled 2, 7 7 15 and 15, as simple as it is. So like this we will calculate. Now let's see how to code this. So now let's look at the code. First here we into input, and here we write the k is greater than equal to n, it will return n. That means we will fill every k in every like every element is 1, so we will return n. Like that is how we will get the maximum bits. If not, we will set the number of, now the bit is f, and the fn, which is the other sum, like which is max we can get, which is fn. Then we will do the loop, and in this loop I will try to find, I will find the number which fills completely the array, like 7777 or 5 or 3333 or 15 15 15 15. So for that I did ll num equal to 1 left shift f minus 1. So here it is 1. Okay, for f equal to 1 it will be 1. Then I try to find f of num star k. Then I do increase f, and if this thing is greater than this, matlab if now this thing, like this is, we calculate here the sum. Now we will calculate if this now exceeds the given sum. If this exceeds the given sum, we will break. So let's say if sum was something like 2 or something like 3, and I have two places. Okay, so here it will calculate 2 and do f plus plus. Now this will be resulted in 3, and 3 into 2 will be 6. Okay, this will result in 3 and 3 6, and 6 is greater than 3, so it will break now. So we will now calculate the number of bits here. Okay, the number of bits, that is k star f minus 1. Okay, how it is k star f minus 1, if you wonder. mm, like f is the number of bits and we have k places, and f has increased here, so this is the next f. So we will do minus 1 here, and we will do multiplied by k. Then we will calculate the remaining, how much is remaining. We want to fill that up. Now we will calculate the next element, that is greater than what is here. Okay, that is greater than the num, and we will minus it with the num, and we'll calculate the difference between 2, like the difference between 7 and 15, difference between 15 and 31, and then we will calculate how much we can we keep there. Okay, and we will return now. So this is the code, and yes, it passed all the test cases. So yeah, it is how it is. We have to do this question. It may be something lengthy or something like, yeah, like it is not that simple. It can be done in a simple way, but this is what approached my mind and I did this